In section 1 of this lesson, we looked at calculating lengths using the sine rule. In this section, we'll be focusing on calculating angles using the sine rule. Please guys, remember to like, share, comment in order to boost the YouTube algorithm to share this channel with others. So let's begin. In section 1 of this lesson, we focused on finding the unknown lengths of non-right angle triangles using the sine rule. Now we're going to focus on finding unknown angles using the sine rule. So key point that we need to reiterate here is that we can only use the sine rule if we've got a matching pair. And this means that we need to know an angle and the side that's opposite to it. Now, if we know that and then we know another angle or side, we can then proceed to find any other missing value. So just to remind you of what we mean by a matching pair, focus on the triangle here. We can see we've got A and the matching side to that would be little a. So that's a matching pair. So it means that if I know angle A and the opposite side, I can use the sine rule once I also know another side or angle. So in this lesson, we will at least need to know side little b if we wanted to find angle B. So we're going to look at what the rule looks like for angles. We talked about what is the rule for finding a missing length. So small letters are on top of our formula for the numerator. Now, if I want to find an unknown angle, we will then invert the formula. So here, to calculate an unknown angle, our rule will be sine A over little a equal to sine B over little b equal to sine C over little c. And like I said in the previous video, we'll not be using all three at the same time. So to calculate an unknown angle, very important bit here, we would need to use the inverse function on our calculator. So at some point, we're going to be using sine inverse to find an angle. So what I've done here is just to show you how to do that on your calculator. So if you look at the calculator on screen here, you can see I've got sine, cos, and tan. But because this is the sine rule, we will only using the inverse of sine. So I've just put here, how do I do that? So if you have this particular calculator, you would need to press the shift, or it may say second function on your calculator, and then you would press the sine button, and then it will come up as sine with a -1 as a power. That's how you now know that you are using the inverse function. So remember, finding an unknown angle, we will need to use the inverse of sine. Beautiful. So we're going to go straight ahead into our first example. Here we're given this non-right angle triangle. We're also work on the size of angle X. So not drawn to scale, so we cannot measure it. And it's worth 3 marks. So the first thing I always encourage you to do is to write your rule down. So we're finding an unknown angle. So sine A goes on top over little a is equal to sine B over little b. That's to bring the angle in focus. Once we've done that, all we need to do now is to substitute the values from the diagram into the formula, and then we're going to solve for the unknown angle. So let's just label. I've got my matching pair. Remember, we've got to focus on that. So the matching pair, I'm just going to call 77 for the angle A, and little a is 20. And X here, I will call that B for the angle, and the matching side is little b. Now that I've labeled that, all we need to do now is to just substitute that into our formula. So A here is 77. So sine 77 over matching side for that is 20. So divided by 20 is equal to sine B, but I don't know B, so I'm just going to call it sine X for the angle. And that's divided by the matching side of that is 14. So like we did previously, all we need to do now is to rearrange this to make sine X the subject and ultimately x for the angle. So what we're going to do is to cross multiply. So I'm going to do 20 times by sine x. So that's going to be equal to 20 sine x. And that's equal to 14 multiplied by sine 77. Beautiful. So remember, my focus is to make x the subject. So first step here is to divide both sides by 20. So I can get sine x on its own. So 20 cancels out here, leaving us with sine x is equal to. So what I'm going to do is to put 14 times by sine 77 divided by 20 into my calculator to get a value. So 14 multiplied by sine 77. We can use our fraction button to do that, and then divide 20. And that gets me to 0.682. And I won't write all the digits because you can store this value as an answer in your calculator, so you use the exact value. Now we've got here that sine x is equal to 0.682. Now we need to find just x, and this is where our inverse function comes in. So the opposite of sine is sine inverse. Therefore, x is going to be equal to sine inverse of the value we've got here, which is 0.682. And you would have had this in your calculator. So at this point, you would have just said x is equal to sine inverse ans. So that answer key on your calculator, what it does is store the answer of what you've put in last in your calculator. So if you press sine inverse and press ans, A-N-S, it will bring up that value. And then you just press equal. So I'm going to give my answer here. My answer is 43 degrees. Now, a key to know that you haven't done the right thing. So let's say you forgot all about your inverse function and you've just done 0.82. You know, an angle cannot be 0 point something, cannot be. So then you've got to think, oh, I forgot to do my inverse, and then you just do that function. So you can see here clearly, same principle apply. Only thing that has changed for the angles is that we've got to invert our formula, put the sine A on the top and letter A as the denominator. Once we have rearranged our formula, we then need to do the inverse of our function, which we only do for an angle. Absolutely brilliant. Now we're going to look at example number 2. So we're asked here to work out the size of angle X. Again, not drawn to scale, and this is worth 3 marks. So we're looking for a matching pair. And we do have 85 degrees, so I'm just going to call that A. And letter A is 13. And the angle that I want to find, I'm just going to call it C this time just to show you. You could also use the letter C. So C and little c. Brilliant. So we're going to write our formula out. Again, we're going to put sine A over letter A equal to sine C over letter c. So now we're going to substitute our values from the diagram to the formula. So sine A is 85 degrees. So sine 85 divided by the matching side for that is 13. And that's equal to sine C, which is x that we want to find. So sine x over the matching side for that is 12. Beautiful. Now we substituted, we're going to now rearrange because we want to make x the subject. So I'm going to do 13 multiplied by sine x. So 13 sine x, and that's equal to 12 multiplied by sine 85. So we want to divide by the coefficient. We want to get sine x on its own. So I'm going to divide by 13 on both sides. So 13 cancels out, leaving me with just sine x equal to, again, we're going to just put this in our calculator. So press your fraction button. Then we're going to do 12 times by sine 85 and then divide that by 13. And that gets us 0.91956, which I said you could just leave it as the answer to get all the digits involved. Now, second step, before we write our answer down, we can see that sine x is equal to this value. We need to get x on its own. So again, the opposite of sine is sine inverse. So x is equal to sine inverse, which you write as sine to the power of -1, of the value that we got, 0.91956. We just put that in our calculator. So I'm going to store that as an answer and then just do sine inverse, press ans to get the raw value. And my answer to 1 decimal place is 66.9 degrees. Absolutely fantastic there. Okay, so we just need to follow our steps, use our formula, substitute into our formula, rearrange to make x the subject of the formula. Now we're going to do our final example and then our key takeaways. So here we're given this question. Pay attention to the language here. Given that angle x is obtuse, we underline that, it's obtuse. Work out its size, not drawn to scale, also 3 marks. So we observe our triangle. We're looking for our matching pair. So we got 44 degrees. I'm going to label that A. Opposite to 44 is 18. That's letter A. I'm going to call this B. And then little b. So we put our formula down. So sine A over A is equal to sine B over B. Now we're going to substitute. So sine A is 44. So sine 44 degrees divided by matching side to that is 14. And that's equal to sine B, the angle we want. So we're going to call that sine X. Divided by matching side to X is 18 degrees. Now we wrote that down, we're going to cross multiply. So we're going to multiply 14 by sine X. So we get 14 sine X, and that's equal to 18 multiplied by sine 44. So next step is to divide both sides by 14. So we get sine X on its own. So this cancels out, leaving me with sine X is equal to, again, I'm going to put all of this in my calculator. So I'm going to do fraction button, numerator 18 multiplied by sine 44, and then denominator 14. And I'm going to write my answer as 0.8931. Again, we can just store that as the answer. Now, I'm going to do the opposite of sine, which is sine inverse. So x is equal to sine inverse of 0.8931, which I've stored as an answer. So I will just do sine inverse answer. So x is equal to 63.8 degrees. I know you will be tempted to stop there, but we've got to focus on the fact that we're told that x is an obtuse angle, which means that 63.3 cannot be the solution. So what I have to do now in order to get the obtuse angle is to do x equal to, I've got to subtract 63.3 from 180 degrees. So 63.3 take away from 180 will get me my obtuse angle. So 180 take away 63.3, and that's equal to 116.7 and degrees. Beautiful. You've got to pay attention to what the question is asking you for. If the question says an obtuse angle, the angle that you did not get, the angle that you got was not an obtuse angle, which means that it has to be the angle that's on the outside of that. That's really the angle we're after. So we know angles on a straight line add to 180 degrees. So if I take away 63.3 from that, I will now get 16.7, which is indeed an obtuse angle. Now, it's time for our key takeaways. Remember, we can only use the sine rule if we have a matching pair and if we also know at least a side or another angle as well. Now, if we're going to find the missing angle, then we use sine A over little a equal to sine B over little b equal to sine C over little c. And just like that, you found the missing sides or angles for a non-right angled triangle. Now remember, we've got other lessons coming up in this series, so therefore you've got to stay tuned, got to make sure you hit that notification bell if you haven't yet, so that you can see when the third section of this lesson is uploaded. Remember, share with a friend, and remember also we do have other exam questions that are on our TikTok page. Thank you so much for watching.